We're going to graph this function in 16, and it has a slant asymptote. I know it does because the degree of the numerator is bigger than that of the denominator, so that means it's not going to have a horizontal asymptote. So if it was the other way around, if the denominator was a fourth degree and the numerator was a third degree, then when x got really big, the denominator would get bigger faster than the numerator. So that means that number would approach 0 when x got really big, because you have like 100 to the fourth being dividing 100 cubed, which since the denominator is bigger, it's going to get closer to 0. If the degrees are the same, like a fourth degree over a fourth degree or a cubic over a cubic, then they pretty much cancel out, and your horizontal asymptote is the ratio of the leading coefficients. So when the numerator has a bigger degree, that means when x gets large, you're raising that to the fourth power and then dividing by x, that same x to the third power. That number is just going to keep getting bigger and bigger because the numerator is growing faster than the denominator. So to figure out what the asymptote looks like, we're going to divide and kind of rewrite this equation. So if I do this out with long division, I'm kind of just going to use this to rewrite f of x. So, alright, so x cubed goes into x to the fourth, x times. So x times x cubed is x to the fourth, and then x times 1 would just be x. Notice how I left the space for the x term there, like right here. So when I subtract, you get negative 3x cubed plus x squared minus x minus 4. And then you see it, right? How many times does x cubed go into negative 3x cubed? So that'd be negative 3 times. So then you get negative 3x cubed minus 3. And then when you subtract, you get that your remainder here is going to be just x squared minus x minus 1. So in other words, what this answer tells us is that when you divide x to the fourth minus 3x cubed plus x squared minus 4 over x cubed plus 1, it's going to equal x minus 3 plus our remainder, x squared minus x minus 1, over our divisor, x cubed plus 1. So since this part of the graph here has a degree where the numerator has a higher degree, the denominator has a higher degree than the numerator, this part of the graph is going to approach 0 when x gets really large. But when x gets really large, f of x is going to pretty much look like x minus 3.